All right, so let's talk vector subtraction. So this is on page 105 of the textbook. The textbook does a terrible job of explaining it, but after listening to me, maybe it'll make some sense to you. I don't know. But anyways, if you can reference page 105. I sort of kind of follow the same examples anyways. Okay, now I just finished teaching this in grade 11, so I know that you guys have heard it before. When the biggest problem with vector subtraction is knowing when to actually subtract. Right? It's always the case. I know just about when to subtract, okay? So I'm going to remind you of that again. So we know that the resultant is the plane plus the wind. Right? Vectors. The resultant vector is the plane vector plus the wind vector, right? If I'm flying my plane like this, and the wind is blowing that way, where am I going to end up? This way. Over there. Somebody in your chair. Over there, right? The wind is going to blow that way. My resultant is my plane speed plus my wind speed, right? Okay. And there it is there in picture format, right? If I'm flying north and the wind is to the east, I'm going to end up over here, northeast. If you rearrange to solve for the plane speed or solve for the wind speed, right? If r is equal to p plus w, well then p is equal to r minus w. And wind speed is going to be r minus p. And I put the little vector symbol over top. Right? So right away you can see that this becomes vector subtraction. Right? So if you're solving for the plane or for the wind speed, it's going to be vector subtraction. Resultant minus plane or resultant minus wind. Right? Now, do you remember what we did in grade 11 to do vector subtraction? We added, but before we added the name.
Oh, you flipped the sign.
Flip the sign, right? Because, like, if the one vector is, say, like, plus 5, what's the opposite of plus 5? Minus 5. If it's, like, 5 meters north, the opposite would be 5 meters south. If it's like north 30 east, then that becomes south 30 west. Right? You flip. I should get a t-shirt that says I flip for vector subtraction. Yeah. Very few people would get it. It would be cool. It'd be like people would be walking down the mall, they'd be like one in about 100 people would go.
Or you just hear a little I like you.
Yeah. This will mean vector subtraction when trying to find the wind or the plane speed. Just nerd shirts. I wonder if there's like an online. Have you been on the internet?
I mean, we watched the cat video when we were gone.
Yeah. It was so scary.
Those cats.
High fives and fist bumps.
Yeah, that's awesome. Okay, so to subtract vectors by components, just like I said yesterday, all you do is subtract the components instead of add them. That's all you do. It's so simple. It's simple. That's all you do. You just subtract them. You don't have to flip. What did you say?
We got these down.
You write down what you need to, Josh. I'm not going to be sitting beside you next year saying, Josh, write this down. You're going to have to make that decision on your own.
Don't give them that look. Get like a little.
Have like a little.
Should I write this down?
Don't text me. Hey, Mr. Bennett, the prof's saying something important. Should I write it down? To subtract vectors by components, simply subtract rather than add. So suppose you have, okay, I've made it very, very generic. Suppose we have vector C is equal to A minus B. Or like plane is equal to resultant minus wind, right? Whatever it is. Okay, so there's my A and my B. Let's solve this. Okay, I'll pause there. I'm going to do my test while you guys jot it down, and then I'm going to do it. Okay, so let's review from yesterday. What are the steps to do vector subtraction? I'm just going to cut these two and put them on the next page so I got lots of room to work with. Oh, I don't have to. They're right there. Yay for me, I'm so smart. Okay, so there's A and B. So what's step one from yesterday? Find the x and y components of A, I guess, and then do the same thing for B, right? So we're going to write A, 12, east, 26, south. So that looks like this, right? East and south. East to the right, south down like that, right? So that's 12, 26 there. So AX, the horizontal, is adjacent. Are you get mad at me? Because I want to make sure people are, like, you know, because you're also hearing it too. You're not just. Yeah, but people don't all do it at the same time. Yeah, there's no such thing as multitasking.
Oh, yes, there is.
Oh, the video.
Split task. Yeah, you gotta show them the video if they don't believe you.
That's a good video.
There is such a thing as there's multitasking.
We're going to show her right away, aren't we?
Yeah.
Let me finish this and then we'll do it. All right. So AX is going to be, now why is AX close here? Because it's adjacent, right? It's adjacent term. You're giving me that why is it close look. You're not sure why.
I was just going to tell you what
How it what?
but you always just
Yeah, you really should, don't you think?
And we always use like.
Yeah, you'd have to be pretty experienced to not draw the triangle. Yeah. So the AX is adjacent, so it's going to be 12 times the cosine of 26. That's our AX, which makes the AY automatically the sine version, right? If, oh yeah.
Yeah, that's.
Yeah.
Yeah. Sorry. Yeah, you're right. That's the way it should be. No, but it's nice to have the X and Y. It is nice. Yeah. It is nice. Okay, so now the next one. Oh, I get complaints because.
You're doing great, Mr.
Thanks, Ryan.
How do you tell if it's negative?
Ignore the
Excellent question. Okay. Why? Now it doesn't actually give it. Oh, you wanted the ant. Oh, that's what you wanted. Okay. Fair enough. Fair enough. Is the answer not there? No, it's not. Fair enough. Okay, so that's going to be 12 cos 26, right? So 12 times cosine 26. 10.8. Now, that is, the x is to the right, so it's going to be positive. The y is to the down. 12 sine 26. 5.3 minus 5.3.
So if it was like.
If it was like.
It was up and be positive.
Yeah, if it's west is negative.
West is negative. Yeah. Yeah. Okay, so the second vector is 8 east 14 north.
Because it's going
Good?
Yes, I explained it.
Thanks, Tara.
Someone's a cheat.
Okay, so here's the second one, 8 east 14 north. So there's our 8. Here again, the x is adjacent. The y is opposite. So the x is going to be the sine of the cos. The x. It's adjacent, right? It's beside, so it's going to be the cos. So we got 8 cos 14. Which is 7.8. And that's to the right, so positive. If one is cos, the other is automatically sine, right? That I know for sure. So that's going to be by equals 8 sine 14. Or 1.9. In this case, there are no units, just because we're just looking at generic numbers, right? Yeah. There's, Yeah.
Why is there small?
Say again, Jeff? Because it's up, not down.
Oh, it's going, okay.
Going up. Okay, so what's the next step in our process now? No, because this is vector subtraction. Because we are going A minus B, you subtract them, right?
Whoa.
Do I have to do a flip or anything?
Yes.
You not add up like all the x values
You-
all the y values and then subtract?
No. You're going the A vector minus the B vector, right? So you're subtracting the B from the A.
Okay.
Now,
So don't you need to add the x component and the y component and subtract?
That's right.
what are you going to subtract? You're going to subtract the X from the Y?
No, you add.
That's going to be a Pythagoras thing, right?
I understand.
Oh,
Right?
I know.
Like really what I'm doing, if you want, think about it, if you want to think about it in a grade 11 kind of way, we're going to add the opposites. So we're going to make, so we're adding negative 7.8 and adding negative 1.9. You're just subtracting. You're just
So
subtracting.
that'd be like 6 point, or no, that'd be like 7.
I'm going to give you the answer right away. No, you don't need to.
Or no.
Because you just subtract, right? So CX is equal to AX minus BX. So that's going to be 10.8 minus 7.8, which is 3. And here, this is good. Now, be careful, because you got negative 5.3, subtract 1.9.
Negative 7.
Right? It's like really the only thing that's different from yesterday is that's a subtraction instead of an add. Literally, that's the only difference.
I'm so smart.
So then you can draw that and just be like, 3 to the right.
Yep, that's exactly what we're going to do. Yeah, we're going to go 3 to the right. Yes, because this is CX,
7.22.
and this is CY, which is 7.2, and this is 3.
This is starting.
Did you just go?
And now that is not going to be R, it's actually going to be,
See.
or it's going to be C, right?
I yelled that for a year. Yelled.
Why did you put C?
Well, because this is supposedly vector C.
So can you put the R?
You can put R. I mean, in this case, it's, why is that 7.2 down?
So why do you not have negative sign in front of it?
Well, now we're just talking about the length of it, right? Like if I square that, it's not going to change it, right? Okay, so C squared is going to be equal to 3 squared plus 7.2 squared.
Why is it?
Because
It's not going to matter. It's just a regular triangle. It's
it's
going to be exact. So 3 squared, I got to stand over here with a light. Yeah, square root.
I
I got 7.8.
So did I, and
7.8.
yeah.
Got a square root.
I don't remember what he said.
7.8. Do we need an angle, Sierra?
Yep.
Yeah.
Is it weird that this subtraction makes
It's your second time seeing it.
PH.
It's your second time seeing it, that's all.
Is that supposed to be theta?
That is a theta.
you read?
That was a little hard. A little hard, right?
Yeah.
Can you have a negative?
How did you decide to I don't mind it.
Hold on. Okay, way too many side conversation, guys. I'm trying to hear what the questions are, and there's so much noise, you guys. It's very distracting. 67 degrees. I will get to those questions right away. $67 degrees, and that's going to be
That's pretty hot.
east 67 Unless it's Fahrenheit, right? South. Or Kelvin. From there, right, that's the start, that's where we started. Right, that's where we started, so that's where our angle's going to be. Right? We go east first and then south, so east first and then south.
Yeah.
It's always going to, is it always going to be tan? Because it's always going to be opposite adjacent. And why is it tan? Because it's opposite adjacent. And why is it second function? Because you're finding the angle. Right?
It's 7.8.
7.8 what?
It should be 7.8 centimeters each.
Yeah. It's 7.8 whatevers. Yeah, east 67 seconds. Well, like whatever unit it is. This is just a generic question, right? Like if it was meters, then it would be meters. If it's kilometers per hour, it's kilometers per hour.
So now, what if you were to do this like 12 kilometers and 8 meters? Do you have to convert those?
Yes, they have to be the same unit. You can't add or subtract unlike units. It's like fractions. You gotta have the same denominator. That's a good question. I don't think anyone's ever asked that. That's it. That's literally all there is to vector subtraction.
Holy crap.
Okay, so like.
That's easy.